Okay guys, so we're going to do today's notes. These are the first notes. All I did was fold them in half. And then these are the second notes. All I did was separate them into two pieces. And then these are the other notes that we're going to do. So those go like that. They're all on Canvas, so be sure to print those out. So we're going to get started with some notes. So before we start, we're going to handwrite some notes. So we need to know the difference between domain and range. So domain and range. Domain are my x values, and that's, I look at a graph, my x-axis from left to right. Range are my y values. We look at the graph from the bottom to the top. Okay, and then we can have two different types of graphs. We can have a continuous graph, which implies that my dots are connected. And to do that domain and range, we can have several options. So if the problem gives us a closed circle, then my inequality symbols are going to have lines underneath, or I get to use brackets. If they have an open circle, then my inequality symbols don't get lines underneath, and I use parentheses. I can also have discrete, which implies that my dots are not connected. And for that, I'm going to use curly brackets, and I'm going to list all the domains, all the x values, and I'm going to list all the y values. Okay? And I'm going to close it off with the curly bracket. So we can either have continuous or we can have discrete. So let's look at some real world examples. Okay? So let's say you're driving down the road. The minimum speed limit is 55 and the max is 75. So the lowest we can go is 55. And the max we can go is 75. We're just going to use x for now because we don't know if they're talking about domain and range. So I want all numbers. I can drive anything that's greater than 55 or equal to, because I can drive 55 exactly. But I have to go less than or equal to 75. So that's a reasonable domain. Okay, well, I have a line underneath. I have the equal to. So that implies that I can use brackets. So that's one way, or I can write it like this. 55, 75 bracket. We also know that they have closed circles. Remember, closed circles mean equal to. Okay? So here it says you must be taller than 160 inches. So I'm starting off at 160. And I'm going to have I want any value that's greater than 160. And it's going on this way forever and ever and ever, but less than infinity. So I can have parentheses 160 comma infinity parentheses, or I can just say I want any x value that is greater than 160. That's that piece right there. I want any x greater than 160. All I did was rearrange that. Okay, so we're selling houses that are more than 120, more than or equal to 120, but less than 160. So I'm at 120, and then I have x, and I want 160. So I want any value that is greater than or equal to 120, but less than 160, or 120 to 160. This gets a bracket, this gets a parentheses. Remember, equal to gets brackets, not equal to gets parentheses. Okay, so I'm going on a curve, and I can drive anything in between 0 and 35. I can go exactly at 35, but I have to go anything bigger than 0. So I could also do 0 parentheses 35 bracket. Alright, so let's do some problems over here. I'm going to do these first. I'm going to do A first. Okay, domain is your x. So I'm going to look at where my graph starts on my x-axis and where it stops on my x-axis. So my domain is at -1, -2, -3. and then I have an inequality symbol, and it's equal to because it's a closed circle, and it stops at 1, 2, 3, 4, or -3, 4. The lowest, the range is my y. The lowest this graph ever goes on my y-axis is right here, which is -1, -2, -3. Y. The highest it ever goes is right here, which is +2. So I'm going to have bracket -3, 2, bracket. Okay. So then we're going to do this one. The furthest left and the furthest right that this graph ever goes. The furthest left this graph ever went was -1, -2, -3, -4, -5. 1, 2, 3, 4 to +4. Or I can do -5, 4, bracket. Okay. The lowest and the highest are my range. So the lowest is my y-axis. The lowest this graph ever went was -3. The highest it ever went was +1, 2, 3, +3. So -3 to 3. Okay. We're going to skip that one. This one's a little different. Those are my continuous graph. This one right here is discrete because I'm not using everything in between. So I have to list them all out. So I'm going to list them in order from smallest to biggest. The smallest x value that I ever used is right here. -1, -2, -3, -4, -5. So this is at -5, 2. This is at -1, -2, -3. 1.5, 1, 1, 2, 3, 4, 0, and 1, 2, 3, 4, 1, 2, 3, 4, 4, -4. Okay, so I'm going to list all my x's: -5, -3, 1.5, and 4. I don't need to write 4 twice. And then I'm going to list all my y values: -4, -3, 0, 1, and 2. Be sure you list them in order from biggest to smallest, okay? Alright, so then you're going to do this one and this one and this one. We're going to come back and do this and this the next day, okay? So I want to come over here and I want to do some more discrete. Discrete functions are really easy to do. So, for example, this is discrete. Ordered pairs are discrete because we don't know if they're supposed to be connected or not. So my domain, you just, ooh, that's a curly bracket. You just list them in order from biggest to smallest. So -6, -1, 0, 2, and 4. I'm going to do the same thing for my range, my y's, in order from biggest to smallest. The smallest one they used was -6. Be sure you do a curly bracket. -6, 2. I only have to write that 2 one time. 3 and 7, and then we're going to close it off with the curly bracket. The same thing for the tables. My domain is my x side, my range is my y. So these are my domains in order from biggest to smallest. 1, 2, 3, 4. My range is 5, 6, and 7. Okay. The map is the exact same way. The domain is the x side. The range is the y side. Be sure you open up with the curly bracket. -1, 0, 1, 2. My range is 0, 1, 4, 9, curly bracket. And then this is the exact same way we just did that other one, okay?